Hello, hello. I'm just tech support.
So thanks for joining us. My name is Jeff Foster. I've got John McDonough here. We're going to go ahead spend the next 30, 40 minutes talking about Cisco UCS, Cisco Intersight, and some of the APIs that we've developed over the course of the last 10 years. So just to kind of break down, UCS is 100% programmatic, and we're going to talk a little bit about why that is, the value of that, and John's got some pretty interesting demos that'll be coming up here as well. So, when we started the UCS journey back in 2009, everybody else was delivering infrastructure, and really the value that we were able to deliver that differentiated UCS is the fact that it is completely programmatic. Meaning we start with a model that defines all of the various attributes that we can configure, completely independent from the hardware. That's where it starts, is the model. From that, we overlay a policy framework that allows us to define how the infrastructure should be configured, the attributes, the various components, how they come together within the system, such that I can configure and reconfigure that environment through this available API. And that available API is not only available natively as a SOAP-like XML API, but also through our SDK portfolio. So we've got SDKs for PowerShell, Python, and a number of other tool sets that are available on GitHub and other developer resources. So with that, I've got a question for you, John. Which came first, the API or the CLI or the GUI?
So, I know the answer, and it's my favorite thing. The API came first. Every product should always be API first, and that's why I love working with UCS API, because the API was the thing.
Right, and even in UCS, the GUI that we've packaged with the platform makes API calls. The same API calls that you write to when you're using the SDKs, or if you write natively to instrument the platform. So the API is really the heart and the soul of the platform. And when we dig down into the architecture, it is defined from start to finish through that API. So in addition to UCSM, we also have an API available for our standalone systems. And I want to talk a little bit about the architecture and help share why this is so important. So here we've got Cisco IMC. This is our baseboard management controller in our standalone C-series servers. So the DME piece is optional, so the DME is actually part of the UCSM environment, but the configuration can be fully driven through our Cisco XML API. So that XML API is either converted into IPMI calls. Since we are a rack mount server, we need to support industry standards with IPMI, or through the storage daemon, because one of the differentiators of Cisco UCS is we offer complete programmatic configuration of the platform, meaning that even elements that don't natively support some of the standard APIs like IPMI, we found ways to configure those elements through our API. In addition, we have the CLI and the Web UI, which are viable options. And we recently announced a new support for a new industry standard, which is Redfish. So we are compliant with the Redfish standard, and this works alongside our XML API. So session authentication. Session authentication works very similar between industry standards as well as our UCS API. So in the case of the API, we establish a secure session, we receive a session cookie, and that authenticated token allows us to perform configuration and operation against that endpoint. You can see the structure here of a login, of a AAA login using the XML API. Alternatively, we support Redfish. Redfish is a RESTful API leveraging a JSON data structure. So you can see here we have in the URI the request for authentication. Once you get access to the authenticated token or a session within the API, you can continue to configure in the same fashion you would with other platforms. So the beauty of Redfish is not only will it work on these standard systems, or our systems, but it will work on all systems that support the standard alongside our XML API. So once you have your authenticated token, you simply reference the managed object by the distinguished name. So the platform has a full hierarchy, the MIT, a management information tree, that defines the schema of the platform, the objects, the attributes of the object, the operations that you can perform against each of those objects. This is still very revolutionary in the world of standalone rack servers, in the world of hardware abstracted programmability. And then of course Redfish offers the same level of capability. The difference being this is defined by an industry standard. I'll mention that Cisco does participate in the definition of the Redfish standard. We have a chair on the DMTF, and DMTF is the standards body that is responsible for defining Redfish. Actually, right under that there's a working group for SPMF. So switching gears over to UCS, and actually the API came before the GUI, and UCS Platform Emulator is a great example of this. So as we were starting out, and as every one of us starts to learn APIs, we want to learn our APIs on a test environment. And the emulator actually allows us to learn APIs, to interact with the system without having any actual hardware. So we've got engineers, we've got product managers that will walk around with a full-blown UCS implementation on their laptop. And this emulator will allow them to interact, write scripts, test scripts, actually fully develop an environment before the hardware even arrives. And how they do that is downloading the UCS Platform Emulator. There's a couple of ways you can actually instrument the emulator. The first, and the one that I recommend, is if you have an actual hardware configuration, a UCS implementation, you can point the emulator to that implementation and you can pull in the configuration. That means that if you're going to perform a sequence of operations, maybe over a weekend, and you want to script that, not only can you test that script on your test environment, but before you even get to your test environment, you can test that script on your emulator. You can test it, you can retest it. So this gives you a very safe environment for you to write scripts, develop your automation before you even get out onto real hardware. It also helps to scale the investments that you've made. Another way is you can actually save a configuration from a system, re-import it to the emulator, or you can create a configuration from scratch, maybe even before the bill of materials comes into to your data center. So within the platform emulator, and actually within all of our platforms that support the Cisco UCS XML API, we have Visore. And Visore is our model browser. It allows you to understand the relationships and hierarchy of the API. So if you're new to an API, the API, and you want to go in and understand how does a boot object relate to a boot policy, or how does a DIM relate to a chassis, you can actually understand the relationships, the attributes, the available operations that you can perform against the various objects. So Visore is a great tool. It's actually available at your UCS domain /Visore. So this is one of the many development tools that we have available as part of our SDK toolkits. So I've talked a lot about APIs, and APIs is the enabler, how, but that only talks to how we can interact with the platform. The platform itself has a tremendous amount of intelligence. So UCS is comprised of two key elements. The first is the DME, the second is the AG. The DME is like a queen bee of UCS. It directs all of the activities that need to happen. So if you want to change an attribute, you're actually going to send that API to the DME. It's going to commit that information to the management information tree, or MIT. This is the database of the system. Then the application gateways, the worker bees, are actually going to make it so, to take that configuration definition and push that down to the endpoint. Take the policy and apply that to the server. So this is really the secret sauce. So the definition itself is completely abstracted from the hardware. And this process of configuring the devices actually goes through a number of steps or stages, finite state machines, or FSMs. So if you've ever seen FSMs in UCS, that's the process that a worker bee or an AG will follow to deploy that configuration. So in this case, again, we'll use the GUI, but in fact, we're using the API to configure some attribute of the environment. That's going to go over to the DME. The DME is going to process that. If it's a valid ask, it's going to be pushed to our MIT, which is the database, and it will persistify. So if 2 FIs, you'll make sure that you get that written to both. At that point in time, your AG will make it so, whether it's a server AG, a Fabric Interconnect AG, or one of our other application gateways. So that's some of the under-the-covers infrastructure and architecture of UCS. And it's really the secret sauce that has helped to make us successful since 2009 in abstracting all of the new platforms, all of the new architecture, as we continue to maintain compliance and backward compatibility with the APIs. So this is a slightly different view, and you might be asking, well, how does this fit into the overall data center and the architecture? And there's primarily 2 different types of activities that you will perform that will touch these elements. The first is a configuration change. So we're going to configure and associate a service profile, a logical definition of a server to an actual piece of hardware. Now that server could be defined well in advance by maybe it's your platform emulator. And in this case, we're going to go ahead, we're going to apply that. That definition is going to come through the API to the DME as we described, persist in the database. Now the AG is actually going to push this down to the endpoint. This is truly stateless computing. That definition is nothing more than a software file. The hardware does not have any preconceived configuration. All of the configuration is derived from that service profile definition through the API. But what about faults? What happens about when the fault, something happens on the endpoint? In this case, the application gateway, that worker B is looking out for the hardware. So in this case, the worker B sees an error, and it will actually report that the other way, up through UCSM. It'll be logged in the database, and then alerts will be sent out through the XML API, as well as through industry standards, syslog, SNMP. So this is how UCSM is working under the covers, and why a programmatic enablement is so important in how we're delivering solutions. And then before I talk or bring John back up on stage, even within the GUI, you have an option to define the XML and understand how the various objects in the GUI are related to one another, the attributes of the objects. So in this case, we're looking at a server. We can right-click on that server and we can copy the XML. So you can see here, we've got a compute rack unit, which is sys rack unit 1. So that management information tree actually has defined this server as server 1. And if I want to go modify some attribute, I can do that via the API. So all of the components, all of the policies, the attributes of the system are defined in this MIT. So John, before we come up, or before we go on, come on up and tell us a little bit about some of the things you've done in developing solutions for UCS Manager.
Sure. So I've been doing this since 2008. So before UCS was generally available, I was working in advanced services, and I was doing API operations with the XML API, and then with Perl, and then with Java, and with PHP. I even have some macros in a spreadsheet that use Visual Basic to connect to the API. I do all sorts of things. It depended on the customer, what we were doing, whether it was automating the deployment of something, whether it was fault collection, management, monitoring, whatever it might be. And there was this idea that customers had that at some point there'd be a limitation. At some point the API wouldn't do something. And I always said to them, if you can do it in the graphical interface, you can do it in the API. They didn't believe it. I said, well, we can. Let's just, what is it that you want to do? And I would model it each time, and I would make it come to life each time in the XML API. And then when Power Tool came out, And when the Python SDK came out, my job got a little bit easier, or a lot easier, I would say. And I could do all these things. I can manage servers and chassis and interconnects and configurations. And so anytime somebody said, what does the UCS API allow me to do? I would get a little exasperated, and I'd be like, everything, everything. But you know, something that came out in 2009 probably started being developed in 2006 or 7. And you think, well, it's not REST. It's not cool. Everybody wants to be cool and use REST. This XML API, I like to think, like me, has matured with age, right? We might be older, but with age comes we're better. So I want to do something. I want to show you something that I think is pretty cool. Who's made a service profile? Who's made a UCS service profile? Did you make it with APIs? You clicked, you did some clicking, right? Who used the CLI to make a service profile? You did some typing, some clicking, and some typing. I think that's a waste of time, clicking and typing. What if you could push a button? A button. Just push it and make a server profile. That would be pretty cool, right? All right, so here's my organization, my Devnet DMZ management, and I want to create some Cisco Live service profiles. Would you push this button? Have you ever made a service profile? Yeah. You have. Clicking and typing? Yeah. Do you want to make one with the API? So just give it one push, one quick push. All right. So the API may be older, but it's still very, very powerful. How did I do that? Button connects to my phone via Bluetooth. Bluetooth makes, the app in here makes a REST API call to an API gateway in Amazon. That API gateway translates that REST post request into a request into a Lambda function. That Lambda function on AWS SSHs to a Win2012 server running in Azure. I got cross-cloud capability. I got multi-protocols going on. The SSH request calls a script in my server that's written in UCS Power Tool. And the Power Tool provisions the server. I could click and click and click and click and click. All right, that's enough clicking, right? And of course, you know, most demos are cool, like, oh, he did it. But anybody ever undo it in their demo? Who saw an undo it demo? No, you didn't. That's not the right answer. Yes. So an undo it demo. Double click. And they are gone. So the XML API, it's been around for a while, older, maybe, but just as powerful as anything that's out there today.
Awesome. That really shows the power of what you can do with the API here, and it really is everything for UCS. But let's talk about something a little bit more interesting in terms of new, kind of that updated API. What can we do in terms of multi-UCS? So about a year ago, we brought to market Cisco Intersight. Cisco Intersight is a Cisco-hosted Cisco-hosted management platform for Cisco UCS and HyperFlex. It allows us to deliver new features, new functions to enable UCS on an ongoing basis. So we're using CI/CD to deliver new functionality every few days, maybe new major features every 2 weeks. It's enabling a new intuitive experience. If a customer calls us and says, you know what, we should modify the experience because it wasn't clear to me, we've made that change. We're enabling enhanced support, so we can actually reach down into your system. If you call TAC and say, hey, I've got a problem with a DIM, we can now say, oh, that server that's connected to Intersight, we can actually generate and upload a tech support file and analyze that using scripts, using the API, to see if we can troubleshoot that in real time or near real time, taking the requirements for you to generate and upload support files, eliminating those completely, and really streamlining and compressing the support experience. offering proactive guidance around configuration, hardware compatibility, telling you if you're running in a supported configuration or if we have recommendations, maybe around driver versions that you should be updating. Security, we're actually able to push security down to the endpoints to make sure that we have a secure environment between, and a secure connection between the endpoint and the Intersight cloud. And finally, we support more than just SaaS today. Last week, we delivered support for a connected appliance, meaning your data stays on your site. Now that appliance is connected to Intersight, so you still get all of the benefits of the evergreen model of Cisco Intersight. And this can connect to systems around the world. We've got over 250,000 servers connected today, 30,000 Fabric interconnects. So from a scaling perspective, I hear customers ask, but I've got 100 servers. We can do that. 1,000 servers, we can do that. 10,000. We say, look, if you have the servers, we can manage them via Intersight. So this is also an API-driven system. We're using REST APIs. So for those of you who like REST JSON API, that is available through Intersight. It's enabled through a device connector, and this is the secret sauce for Intersight. This is what it all comes down to. The device connector was introduced in July of 2017 in UCSM version 3.2.1. In IMC software, all of our M5s and M4 starting with 3.0.4. This device connector is actually embedded in firmware. Once you have the device connector, just by simply connecting to Intersight, you can get device connector upgrades. This device connector ensures secure communication between the endpoint and the cloud, and it continues to deliver new functionality to the endpoint at the same time we're delivering enhancements to the Intersight platform. So your system gets easier to manage. You still manage and control your firmware, but you can enable that through Intersight. So I talked a little bit about support. This is an example, a fairly complicated example, but it looks simple in the slide. It was actually just before the new year, we had a customer call in and their system was seeing some behavior they didn't expect. And so they called their sales rep. Their sales rep opened a case on their behalf. This is where APIs become interesting because we were able to generate and upload the diagnostic files that we needed, brought them in-house, analyzed them, and within a half an hour, we were able to isolate the issue, give them a recommendation for remediation, and the customer didn't have to do anything to enable that. Again, APIs in UCSM, APIs in Intersight, APIs in our tax system. All of these are enabling a much, much better experience. So we have resources, obviously, to understand the APIs. We've got a set of API documentation. These are available at intersight.com/API docs. Information about the model, the methods, the error handling. We've got information on references. So actually one of the things I think is the coolest part of our API documentation is the embedded reference and client. So for all of the various manage objects, we have a definition, and you can actually go through, you can open an embedded client in the browser and start to run queries. You can filter those queries. So before you even write a line of code, you can isolate the attributes, the objects that you're looking for, using an API in the client to understand how am I going to structure the query? What do I really need to isolate to perform the operation that I'm looking to perform? And this is also capable of managing everything in Intersight. In fact, the GUI communicates to the API. Now I like John's button. Let's see if he has something that he can share with us on Intersight.
Well, so I don't know if anybody recognizes me from YouTube. Anybody recognize me from YouTube? I got a video out there that's got about 1,000 views. So I assume somebody here would, no. So I do have a video. And in my video, I used the Echo to manage a UCS manager. Now, I don't know if AI devices or IoT devices ever get jealous, but I've been working with Alexa here. It's been a little finicky. I didn't ask that. See, again, stuff I wasn't interested in. So let's see. Remember, I love this button, but let's see if we still get along. Alexa, ask Cisco Intersight.
Welcome to the Alexa skill for Cisco Intersight. You can say things like, what is my fault count? Or you can say provision an HX cluster. Or you can say provision a server profile.
Provision a server profile.
Why don't you ask your button, since you love it so very, very much? Are you even listening to me, or are you looking at your button? Why don't you try asking me nicely?
Please provision a server.
I created a server profile for you, but I didn't like it.
Now, normally, see, finicky, right? A little jealous of the button here. She would tell me, or Alexa, I'm not going to apply a gender, would tell me what the name of the service profile was. So I'm just going to go look at Intersight to see.
I don't know that one.
I know you don't know that. I'm going to go look at Intersight to see what she provisioned for me. And sometimes, you know, Alexa's a little passive aggressive. Oh boy. Oh no, we're okay. Little passive aggressive. We got to fix it. We got to repair our relationship. But I think maybe doing this, things are going to be okay. I'm a little nervous though. Oh. She called that service profile, I don't like you. Well, anyway, we got some relationship issues we got to repair. Anyway, it's supposed to be a little bit fun. You can still do the same things that you do with the button. You can do with the Echo, Google Home, any of these other IoT devices with the user or the REST API. So I hope that was fun.
I do know one of our colleagues, David Soper, has a video. She didn't seem to talk back to David, so maybe it really is the button.
I think David is a little bit nicer to Alexa than I've been. I don't know if he has a relationship with the button or not.
So with that, we want to say thank you. We wanted to end a couple minutes early. There is the Devnet Amazing Race Challenge. So if you haven't had a chance to go through, answer some questions on UCS. We're giving away an iPad here at the top of the hour. So
best time wins the iPad.
Yeah, take advantage. We've got some ice cream in the back. The Amazing Race. Answer some questions. John and I will be up here if you have anything you want to discuss. And we really appreciate your time today and your engagement. Have a great rest of your Cisco Live.